Welcome to another episode of the HVAC Grapevine. I am Chris Hughes, along with me, my co-host Michael C. and Franco.
What's going on?
Well, man, tonight's a fun night. I have a guest tonight that is a very good friend of mine. We have a long history together, and he has been one of my HVAC mentors for quite a few years. You've met him.
Yeah.
And he's entertaining. So tonight we're going to blow it up. It's going to be a good show. So
sweet, dude. I'm excited.
Probably lots of laughs, lots of entertaining stuff we're going to talk about. We're going to get nerdy, of course. That's always the case.
I mean, that's the grapevine.
That's the grapevine. But before we jump into the guests, let's talk about the week, man. How was the week?
Man. What
news do we have?
Good, man. Week was good, man. I had some crazy ones, dude.
Tell me
Brian Orr texted me. He said he had somebody watching his video on sweaty ductwork, and he emailed me and CC'd me in there, and nobody's been able to fix this. Was it like a golf clubhouse? I was telling you. Did I tell you about it?
Dude, hold on. Let's just time out for a second. Did you just tell me that you got a referral for business from the Brian Orr himself?
The man himself.
I think he just made it to the top. You know what I'm saying? You might as well quit, retire now. You know what I'm saying? Sell your name and just just go to stuff based on your name at this point.
That's it. I'm just going to go to like training events now.
That's what I'm saying. Show up, run out the
one
grapevine.
Call, I'm done. Dude, I was so honored, dude. I was like, what's going on?
You did tell me about that one though. That's the one that had the kitchen hood exhaust and it had an intake that wasn't running, so there was like no makeup air. The building was super negative.
No makeup air, man.
5 pascals of pressure.
This camera again.
You always have a problem with that camera. But here's what we're gonna do. We're gonna waste no time and bring the guest on, because what you're talking about, me and this gentleman have spent many days together doing that work exactly right there.
Nice.
So Matrix HVAC is the company, and Leif Wismar is my friend who runs it. Leif, welcome to the HVAC.
My man.
Hey guys, thank y'all.
Good
to
see you, bro.
Only been like 3 years, bro. I've been like trying to cast that net, be like, come on, you could do this.
Yeah.
And there he is.
And I'm gonna try not to laugh, even though I'm gonna try to be correct and everything, but I know y'all are just gonna make me laugh. But it's okay. We'll get through it.
Dude, the year Chris brought that shuttle bus, man, we had some funny times. That was a good one.
All good stuff.
That was a blast, bro.
Leif, how many jobs do you think we have conquered together that were problematic due to a kitchen hood exhaust?
I don't even know if we can count. Too many.
That's like
so it's like number one.
Yeah, we would get people ask me all the time, like, what do you miss, man? What do you miss, like, from being in the trade every day? Man, there used to be this game that me and Leif used to play a lot. And he still does it with the old company and all that, but we used to play it together very well. And we would always get the call. And it's weird, like the mechanical contractor typically gets the call, and there's like this imbalance of flow. They got mold growing. We're talking about a big commercial building, whether it be like the airport. Leif, what else did we do?
That's
we did
man.
Quite a few restaurants down in the city. Yep. I'm trying to think of some other places we did. But anyway, it was typically we'd get a phone call. But at this point in my career, I didn't quite know how to analyze the building very, very well. Right. And I did, I'm just going to take it back, man. I didn't know what enthalpy meant, right? And I remember Leif and me being on the job. He's got these probes. I'm like, man, what are you measuring? And he's like, enthalpy. And I'm like, what?
Who's that?
Yeah, who's that guy?
I think I went to high school with her.
And so I was, even though I didn't quite know enthalpy at that time, I still knew my temperatures, my pressures, right? I knew how to make sure a system was running well. And
Yeah.
I learned exactly what enthalpy meant through Leaf, right? And but on the flip side of that, Leaf, you would tell me all the time, you would say, "Hey man, I might know what enthalpy means, but I don't know pressures, temperatures, all that very well." He goes, "I'm no bona fide mechanic. I just
Right.
know how to put these probes in there and see how much work the unit's doing. Like that's what I know."
Right.
There's a difference between those two mindsets. So together as a team, we worked very well. And I would get the call, and then I knew I did not know what I needed to know. So I would say, "Hey, Leaf, me and you together, bro, like, peanut butter and jelly, like a sandwich. Here we go. Let's go knock
That's
this
right.
out." And we would go do investigations, and we would do big time investigations, and
Yep.
we would charge for it. We'd charge a
Yep.
few grand, right? I would
Hmm.
say the cheapest investigation I think we did was like $2,500,
Yeah.
but it also scaled up to somewhere in the neighborhood of I can remember one right off the top of my head we did for 12.5. I don't know if you remember that one.
All right. After the show, I'm gonna write some notes down. All right. Woo! I like hearing
Yeah.
that.
But
Wait, but how did you guys get? How did you guys meet up? I never got that story.
That's a good
uh,
question.
Goes way
I don't
back. I mean,
yeah, it
Yeah.
goes way back. I'm trying to
Yeah.
remember. I don't remember the first
I
time
remember.
how we
I
met.
remember you guys were doing podcasts back in the day, man.
Yeah.
Yeah, yeah.
Yeah.
Leaf had let me jump in this conference room. That's where I started the podcast.
Yeah.
Uh,
I remember watching a video where he made his own unit, dude. That was crazy.
yeah, we're going to
It was
talk
in the
about that.
warehouse.
Well, so we're going to get into talking about that a little
I'll
bit.
slow it down. I almost
Yeah,
got the
so
camera again with the
bro, you
hands.
want to give away the whole show?
Damn. I'm like, no.
All
I
right,
didn't get the itinerary, guys.
we
Sorry.
could go through the history lesson the whole show, but that's going to bore people. Let's get to the fun stuff, right? Let's talk about Leaf and what Leaf does. Leaf, you're a professional engineering firm, okay, and you specialize in HVAC. But I'm going to expand on that. You specialize in like air tightness and building science in HVAC, right? It's not
Yeah.
just HVAC.
Right.
So, can you expand on that a little bit and tell us, like, kind of like in broad, what are the topics you focus on and what does that look like?
Yeah. So in general, like you said, everything we do engineering wise is all around HVAC. So, like we'll do building surveys and building analysis, and then if someone has a problem or, like you're saying, mold, mildew, negative pressure, so we'll go in there and we can just have like a list of things we'll test for. So we'll like do a little drawing layout. We'll do a heat load on the building. We'll use a blower door test. We'll measure if the building's positive or negative pressure. And then we'll go through the air conditioning equipment. Now, we do not, like Chris says, we don't put gauges on the equipment. We do a performance test and we'll say, hey, the unit's performing well or it's not. And if it's not, we'll recommend to have a technician fix it because we're not good at that. But so once we go through like these whole little steps, once you gather all the information,
Yeah.
the problem comes out and the solution to the problem comes out. So we have like a whole little list of testing that we do on some of the buildings and all. But kind of like what you're saying, we'll still do the the AutoCAD drawings, the the heat load calculations, equipment selection. We'll do commissioning work. We'll do testing and balancing. And just about everything we do is what a mechanical contractor doesn't do. And so we do a lot of work specifically for mechanical contractors. That's a majority of our business.
Hold up, Leaf.
Yes,
So
sir.
this is the part that I think originally why we worked so well together, and I think needs to be explained. So when people think of like HVAC engineer, they don't typically look as an HVAC engineer as somebody they're going to work with a lot,
Right.
because we think as technicians, well, HVAC engineers get their work because they work with architects.
Correct.
Architects do drawings. Architects do not do mechanical engineering drawings, although some try and probably shouldn't be trying, but that's another story. And then, they hire an engineer to come in and do the engineering drawings and the structural, the mechanical, the electrical, and the engineers pipe in all of those drawings underneath what the architect drew for the shell.
Right.
But the so that's where we think like the mechanical, where you guys get most of your work. But that's not the case in your case, right? That's
Not for
very,
our company. Right.
yeah, for y'all's company, that's very little.
You-
Y'all
You're
actually
you're a
do.
different type of company then. Yeah.
Yeah,
From what
we are.
yeah.
We fit a different niche, but that's what we like. We don't like when we're doing a drawing or something on the computer and say it takes a day or something. Like halfway through it, I have to stop. I have to go in the back. I have to fiddle with something, work on something, and then come back because it's too much for me to be in front of the computer that long. But
All day.
like
Yeah.
what Chris is saying is when we get together, he knows the air conditioning side of all the equipment. And then, well, now he knows just about everything. But when you're working together with when you're working together with a mechanical contractor and bouncing stuff off back and forth, you come up with a solution a lot quicker.
Yeah.
But so if it was just us, you're only going to get X amount of work done. If it's just a mechanical contractor, you're only going to get a certain amount of work done. But when you
Right.
kind of pair up, the whole goal is to get the problem solved, get the
Yeah.
job over with. And if it's a job that's, bleeding money, the whole point is just to get it over with and to end it and get the solution. So for us, that's what's good and that's what we like to do. And so everyone in
So
our office is geared the exact same way. So
you guys
we're
are like
a
Voltron.
lot
You
of
guys
hats.
combined,
Yes.
turn into like this super HVAC engineering
Dude,
on-site consulting firm, knocking
people
it out
loved
the
it,
park, man. I love it.
And I tell you what people love the most is we would walk into a job, and I'm thinking of that lab we did way down south. Do you
Yep.
remember? And we
Yep.
walked in there together and we said, okay, here's how this works. He's the engineer. I'm the mechanical contractor. We work together. It's a package.
Love it.
You buy what you're getting. You get us both. We do not point the finger at each other. You can only point the finger at us together as one unit. We
Yep.
take all the responsibility and we
Yep.
solve everything. And
Dude,
that's the
that's
way we
half the
operate.
problem is the finger pointing game, dude. That's half the
Yeah.
problem right
That's got
there.
to end. And
Yeah.
that's
Yeah.
like
And
we'll do a
so,
lot of commissioning work for like Navy bases and stuff. And so we're working with mechanical contractors and they're not under our envelope. We're third party. But first thing we do is explain to them, hey, look, man, we're doing this job like they're telling us to, but the whole goal is let's get through it, get everything done like the drawings show, and get off the job. Not, hey, the mechanical messed that up or the engineer messed this up. No, let's all get
Yeah.
together, work out the problems, and move on. But
Yeah,
that's
I
the
love
idea.
how you guys are both there. So if there's something weird that pops up, the both of you are hitting it right on
Yes,
site,
indeed.
writing
it's
down
happening.
notes. That's
Yes, indeed.
dude, that's gold,
So
man. Yeah.
Oh, it was. It was
yeah,
fun.
we definitely had days of gold. It almost became too easy, to be honest. Like too easy where we started to joke. We would joke around in front of the client when we shouldn't have been joking around. But our confidence level was really, really high, and it was like
Right.
we got too confident, but we still got the work. But
So let me guess. You start seeing a lot of the same thing, and it becomes a little
well,
bit.
yes and no. I mean, so let's talk about that lab for a second and tell that story. And this has been years ago, so I'm trying to remember. But if you could imagine, there were, Leaf, you remember this job. There was probably, what, 4 or 5 dedicated outdoor air systems that are moving a constant volume of airflow into a lab. Now, we're talking each one of these is, what, 20 tons? And I think that was, what, 150 CFM of flow per ton. So let's do some quick down
Golly,
and dirty math. We're
20
doing a
ton. You said as a DOAS
150,
unit.
yep, 150 times
Is
20.
is there
That's
a couch in
3,000
there where you could like?
times 5. So if you could imagine
Whew, no, I cannot.
15,000 CFM of flow, right? Coming into the building nonstop, 24/7,
Whew.
right?
Was this like
Into this lab.
hibachi?
No, this was a lab that was where
Oh,
they
that's
were
right. I'm
testing.
sorry.
They were testing
The
chemicals.
monkey shoulder. Monkey shoulder.
It'll
So
do it.
they had to have nothing but positive air being blown in this lab. Well, at the same
Oh,
time,
right.
you can't pressurize the building, so you have to have the exhaust going. So they have
Okay.
15,000 CFM of exhaust and 15,000 CFM of airflow coming in. I mean, the air
Wow.
exchange rate's insane in a place like
Yeah,
this.
that's cool.
And we got called in, I think, because the bathroom was growing mold. Is that what started that one, or was it something else?
And
I
this
thought it
was
was the bathroom. I thought it was the bathroom was growing mold, and then they
the Wuhan lab. What's that?
They didn't have enough ventilation. That's why.
We have to keep the humidity up for the bats. We don't understand why there's so much mold here.
So we go in there, and I think that. So first off, tons of mechanical problems. Like whoever was working on these DOASs, they had 3 Aeons, one. I can't
Oh,
even
that's
remember
the
the
one
name
from
brand.
Tampa over here. Aeon, I think. They make them
Yeah,
like
three. There was 3 Aeons.
yeah,
One of them was a
not a
Fantech.
Aaron.
Anyway, they had two different models. There was like three totally different DOAS models on site. They had all been tampered with. One was monitoring supply air. One was chasing humidity. The one of them had the volumetric flow rate was going up and down. So
Oh
those are
wow.
more or less my issues. At the same
Right.
time, Leaf went into the building, did a full kind of rap sheet on what do you have bringing air in, what mechanically do you have bringing air out. He's running through the scope of
Right.
what is all this rating for, and does it match? Because Leaf knew right out the gate, he's like, if we have a negative building, something either was added into the lab and wasn't discussed, and which is creating more exhaust than the air we're bringing in,
Right. Right.
vice versa. And my
Something
job
new.
was to go, yeah, right. He was looking for something new. At the
Right.
same time, I'm looking at the equipment to see if it's performing and seeing if there's a
Right.
possibility for an air exchange rate to be changed so we could actually fix the problem.
Now,
So
Leaf, do you get with the building supervisor and say, "Hey, I need your mechanicals. I need them up front. I need airflow."
100%. That's the first
yeah,
thing we ask for is, do you have drawings? And
That's
and
if they don't,
99% of the time they never get shown.
yeah.
Damn.
And then when they do get the drawings, the first thing we do, and we pay for it out of pocket, we'll take
Yeah.
their drawings and we'll scan them so we
Oh,
can have them
dude.
electronically and save them. And then we give them that scan back and say, here's your hard copy, plus we made a digital, so they don't get lost in the future.
That
So,
is sweet.
but
That's
yeah,
cool.
so it's a struggle. That's the first thing we ask
Yeah.
for. And I think that job, they did have some drawings.
I thought,
Yeah.
yeah, they had something, and I think it ended up being that they had added on more exhaust to the lab, and that's what created the negative building, right? And then
So
I
they were
don't,
pulling more out, and you saw on the plans it wasn't that many hoods or whatever for those labs. Okay,
Yeah, you
cool.
look for those discrepancies, and I think
Yeah,
on the office side, I think it wasn't installed exactly like the drawings. Like sometimes they'll do like value engineering. They'll
yeah.
save costs, but then it kind of limits them. So
When I went to the first symposium, I was like, "What is a DOAS unit?" Because they've got just a residential package unit up there where this DOAS thing should be. I was like, "Is that okay?" And they were like, "No, that's not going to work." I think it was oh, I forgot who he's in our group. Was it Paul? Oh, I forget who told me. But I was like, "Yeah, this ain't going to work, man. We're exhausting all these kitchens, all the bathrooms, and all they had was a package unit. What is that?"
so Leaf shot me some pictures right before the show started, and I tried to put them together. But Leaf,
yeah,
this looks like a DOAS to me. It
it
looks like
actually
it's
is.
all pressure. Is it a
Yeah,
DOAS?
Wow.
you're right.
Is that going
You
to
want to
replace residential AC? Oh, did you
think
invent
so?
something?
It's a 2 ton or 1.5 ton. I'm just kidding.
Okay.
No, that is for offshore. Everything's stainless, everything's copper, everything's
Dude, that
coated.
is sweet
and
looking.
and they have the same problems offshore that you have in the residential market, commercial, industrial.
Mhm.
And so all we were doing on this one was we were doing like confirming the performance. This was at the manufacturer's facility, and then we were just documenting and checking enthalpy splits, airflows, and doing the calculations to see if it performed according to the original specs that it was built from. But
So, Leaf, you were talking about, you just made a comment and you sent me a picture of this. And this is interesting because I personally have never seen this until you sent me the picture, which is weird because we've known each other so long. But you just sent me this picture and you said copper. And so
yeah,
I asked you earlier, I was like, man, what did you coat this coil with? And you're like, oh, that's not a coated coil. That's a copper coil. And I was like,
What?
what?
What the heck's a
Yeah,
copper coil?
yeah, we're prepping it to coat.
Wow.
got it. All right,
So
Lee, tell
degrease
us
it and yeah.
tell us what we're looking at, bro. What do you mean copper?
Unless this is like secret stuff you can't say, that's fine.
No, no, it's not. This is I believe it's a standard carrier unit. And in the catalog, you can actually select a copper application for just condenser or condenser and evaporator. And so I
Really?
believe this unit, we do coatings for units. And and a lot of times you can buy them through the manufacturer, but the lead times, sometimes it's just too much. So then people would say, hey, look, I got this unit. I need you to coat the coils on it. So this particular one's going like on a tugboat, so there'll be saltwater environment and stuff. And I
Wow.
believe all they want is the condenser side coated. So I guess, if there's salt spray going on and it sucks through the coils, it could corrode them a little quicker. So copper is supposed to help with the corrosion, and then they go one step further and they put or we put the little coil protection on there, and we use just modine. But yeah, so there's a lot of little things, and so again, that helps with the tugboats. But when you do offshore, they go so many steps more. Like that
Oh,
previous
really?
photo, it's all stainless steel, and everything's designed to just last in a harsh environment.
That is
So
cool,
they
man.
just all kinds of different levels.
Yeah, everything gets stainless, and
I
it's a
didn't even
certain
know you could
grade.
order a copper fin. That's neat, man.
Yeah.
Yeah, it's pretty cool. But one thing that's interesting while I have this picture pulled up, see how the base of the unit is painted steel? And years ago, I'm like, why don't they do a galvanized base, or why don't they do this? And the people on the oil rigs and everyone involved in the oil industry, it's easier for them to grind down rust and paint it again versus trying to regalvanize a base in the field. So
Wow.
all the structural members are all just painted
Painted
steel and
steel?
stuff. Yeah.
Wow.
So like,
That's
but anyway, it's just kind of interesting. I never knew that. But so that's how the specs are. They want to, and there's a certain painting process, sandblasting
right.
process, priming process for the steel. It's very rigid, but then, and so it's all just following the manufacturer's specs and all that they're given.
That's neat. So copper fin, copper tubing, you get less of that electrolysis through there, and it doesn't separate. That's sweet.
Yeah, for like the salt water, the aluminum kind of gets eaten up a little bit with the salt water.
Yeah, I noticed that. The aluminum does pit really bad. Yeah.
Yeah, yep.
So there's another picture I want to show. This one has a story to it. This is a job we did together.
I just want to see the thumbnail of Leif in the woods on the bed again. That's all I want to see. Sorry. I mean, was that AI? I mean, I got so many questions. Maybe I'll leave it for after the show.
I went up north to my cousins and it was snowing, and we never see snow here in the South, and it's just nuts. So I went outside and just sat in the snow and act like
So
it
it's
was
real.
Yeah, it
Dude,
didn't last long.
Dude, that would be my Christmas card to everybody in the family. Dude. That is awesome. I got to give it to you.
Can't
When Chris sent me that, he's like, I'm going to send this out. I was like, bro, what is that? That is crazy.
I don't even remember how Chris gets these photos.
That's right.
They just pop up.
Well, you know what? He told me he has your login information for your iCloud or something like that. What was that, Chris?
Oh man, it's some drone planes from military friends. You know what I'm saying? Like, hey, I need a shot over here at coordinate such and such, and they're like, bro, consider it done. Yeah, air conditioner background has power, bro. You know what I'm saying? If I got friends in high places and I'm like, hey, you want your air fixed? I need a favor right now.
Exactly.
That's it.
Leif,
good.
Power to grapevine.
Dude, tell them the story behind this unit.
So it's another DOAS application.
Okay. But it ain't a DOAS. Well, it is and it ain't, right?
Is it
this is actually
downflow?
a standard carrier package unit, small tonnage. And DOAS units are very expensive, depending on what a customer's budget is. They may or may not be able to afford it. So to stay within this particular job's budget, we took a standard carrier unit and converted it to a DOAS. So this unit, in order to do that, we had to replace the condenser coil because we needed an intertwined circuit. And I think this was
the evaporator coil. I think you said
yeah,
condenser
you're correct.
coil.
I'm sorry. Yes,
yeah,
evaporator coil.
I remember that because I had to do it.
Yep, that's right. Because we can't solder. You ever seen an engineer solder?
You ever seen an engineer solder?
It doesn't work. It doesn't work.
So,
But,
Chris, you laid hands on this thing, huh?
Oh yeah.
We all did it together. So
That's awesome.
This was for a plant, and they knew. So the part of the story I think you told me was they knew that no matter what they bought, it was not going to last 2 or 3 years because the environment's so corrosive.
It's
So
true.
it's like, so when you have a client that's like, hey, I don't want to spend $50,000+ on a piece of equipment that I know is not going to last 2 or 3 years.
Right.
Leif basically was like, well, shoot, we could probably build a carrier base model unit up into a DOAS unit and get 2 to 3 years out of it. And so we were like, heck, let's do it. I mean, we could bring the price of the unit down way down. We know it ain't going to last more than 2 or 3 years, and they don't care. Because if it comes in, less than half the cost, they figure they won.
Yeah.
And so they're going
to
they're going to buy a new one every 2 to 3 years, and if they get anything past that, they're just like awesome. So,
yes, exactly.
we made a
you
makeshift
made your
DOAS.
own DOAS unit. You should, dude. That's I gotta give hats off to you guys. That's really cool.
It was a fun project.
It is pretty cool.
Now, this plant, if I'm not mistaken, they had their own power source, so it's a DOAS, and we put a RT. Is it RTD? What's the electric heat strip that pulses power? I'm trying to remember. There's a name for that. SCR heater. We put a downstream SCR heater.
Reheat in the ductwork.
Nice.
So
and that way,
yeah.
Oh, go ahead, Leif.
Go ahead. It's not energy efficient at all, but when it comes to the plant, they just want to make their products, and so basically the unit just discharges 50 to 53 degrees all the time, 24/7. And if the space overcools, then the SCR heater pulses on to try to maintain that space temperature. So that was basically the whole design.
This is the first time I remember us really getting into the raw wall controller. You remember that? Like we didn't know how this unit was going to perform necessarily because it was a 2-stage unit, and we were trying to drive that cooling capacity way down, right? And so we were like, man, we've looked into the raw wall controller, we put it in there, and we did some test running in your lab in the back to see how this thing performed, and we learned, man, we could get this thing to trickle down to nothing with that raw wall controller and controlling the fan speed. That's when we knew we were onto something pretty interesting.
Yeah, that's right. So we did a whole bunch of testing and data logging before we sent it out, and so they're actually still using. It was 2 of them. They're still using both of them. I mean, they've had to do repairs.
Oh man, they're like more than 5 years in, dude.
Yeah, but it's exactly what you said though. They even said it. Hey, if I get anything above 3 years, great. So it's just a crazy job. Depends on all the customers are different, but that's how they wanted it.
Got a question. Someone says, can you build a small BTU DOAS unit for residential?
Man, we can build anything if you got some money, fellas.
Dude, you guys are crazy.
We can for sure. And we're kind of messing with that a little bit with Chris. Like we'll bounce stuff back and forth.
There's an idea on the table right now, but we can't go into it because it's proprietary, man. We're working on something.
All right, guys.
Secret,
tonight we got the HVAC bad boys. We got Will Smith and Martin Lawrence over here. Bad boys of HVAC, building their own DOAS units. I didn't know you guys did this stuff.
Look, Leif. Look, what did I tell you? There's a need.
I know. I'm with you 100% on that.
I don't know who AC Super Cool is because I'm not sure whose handle that is, but just know that somebody's working on it. Just saying.
I mean, they do have on the commercial side. They do have split DOASs. We put those in homes before. You got your package unit DOASs.
Oh, it's aging.
But what Chris and I were talking about is if you could do something smaller, more economical, easier to install, like on existing homes, that would
Yeah.
fit the market better because new construction, and if they budget for them, you can put a DOAS. We've done that with homes, but
Lee, do you have a picture of the KT fitting by chance on your computer?
brother,
I mean, people are probably wondering, like they're probably thinking we're joking, but what they don't know is we have a history of like building products together and coming up with ideas, and we've tried to push some out to the world. And our first one ever was the KT fitting, but
What is that?
we,
I'm just a
we
residential guy. Come on now.
I don't. Do you have it? Do you have the prototype at
I
your?
still have the piece. Yeah, I can
Dude, you
grab.
gotta, yeah, grab that thing, boy.
You're gonna get us in trouble.
Dude, you guys come up with some crazy stuff.
Dude, we used to sit around and like think things up, and then we would act on them and be like, "Oh, we should
Yeah.
build that. We should build that." And then we got stupid and wasted a lot of money and built stuff. Then we were like, "We should find somebody to buy this."
And you would have to be the Will Smith because you're tall.
Can you see
Oh,
this?
what is
This is-
that?
So that is the KT fitting we
KT?
came up with, and the idea behind that fitting. Now we tried to get that licensed and push that out to the world. It didn't work, and there's a long story behind that. But the idea was you would hold it up for me, Leaf. Hold
Yes,
it up.
sir.
The idea was it would pipe into your drain line. It's about 6 to
Okay.
8 inches in length. It has a 22.5-degree angle on both sides. This way you pipe it in, and then you would have like threaded caps on the 22.5-degree angles. And we
Okay.
thought, what a nice way to clear out your drain without having to cut the pipe on. Because a T, right? You have this was an idea before the whole like stuff they have now.
Right.
But before you could put a T in just to pass code. And a T, you can't get any of your nitrogen fittings to turn in a T. So we were like,
Right.
man, why don't we just make a PVC fitting that's like
Right.
a commodity that goes in
Yeah.
every drain line, and
Right.
you could put your fitting in and it could make the 22.5-degree turn. So you
Exactly.
could blow your drain line from both direction,
Right.
clear anything.
And you can
That was the
cable
idea.
it with that nice slope that you got on there. I got a
Yeah,
cable, an auger that does well with that. That'd be nice.
Now
Yeah.
leave, turn it this way.
This way.
No, other way. Put it
This
back.
way?
Put
This
it-
way.
No,
This way.
one
This
more
way.
time. One more time. One more time.
Like this. Alfangu.
Look, I'm trying to show people why I got the name KT.
Oh, sorry.
Oh.
Is that-
Wait, flip it. There it is. K. It's a
Yep.
K, and it's
Yep.
a T. KT.
and it's got a little
KT.
logo there. It says T. So it's K and then T. But
I
yeah,
get it.
no,
The
this was
KT.
a fun
Okay.
one.
KT.
Gotcha.
It's the KT.
And it's got
Out-
the little. It's prepped for a little slip in for your PVC and all that. So if you were on the down,
Is that
slope,
3/4?
you could extend it.
That was
It's
a 3/4. Yeah,
Yep.
that was
Dude,
our
that's
product.
awesome.
That was product number
Yeah.
one, man. We ever created. That
Yeah.
was probably what 15 years ago.
It was.
Damn.
It's showing our age.
Going way back. Whew.
Chris.
Bad boys for life.
All right, man. Let's get back to a fun topic. So you seen that crazy DOAS we worked on years ago? Now this was for a lab, and we had to keep one room neutral, one room negative, right? And
Yeah.
Leif, you can expand on that, but this was your project, and I helped you on your project. You kind of drove this bad boy, but explain this picture in reference to that DOAS.
Ooh, got the
Yeah.
wire on there.
That's that's a long time ago.
Yeah,
But
it was.
basically, we gave them a digital readout so that they could know what the pressure is in both of the labs, so that they would know that that the system's working properly, and it'd be a quick way to shut the system off in case there was an emergency. But I believe that's a differential pressure and display with a transmitter, and so if the I think we had a motorized damper, and so
I do
Was that-
remember the job. I remember the job well. You want me to give you the rundown?
yes.
We decided we were going to put the two DOASes in to keep a constant volume rate being produced from the DOASes. We put those that you built. Those are pressure differential boxes that would control exhaust fans in case the room got too pressurized more than we wanted. We decided to run the exhaust fan and then vary the speed of the exhaust fan to control the room pressure. And
Yeah.
that box with the differential pressure is what did that.
Yeah, that's right. And the reason
Woo!
for it is they had multiple hoods. And if they would manually turn a hood off, you could become positive pressure. And then if they
Right.
turn multiple of them on, you could be negative. So that was a way of modulating it, a simple, cost-effective way of making
I
sure.
have had
Dude,
I've
I
had
am
a lot of
loving this. This is
cool,
cool.
yeah.
This is really
Well,
cool stuff.
this is something we've talked about a lot. I have pitched to even my team is
Mhm.
there's a need for this right here to be something you just buy and it's ready to go. You know what I'm saying?
Okay.
Rather than having to build it like Leaf had to do here. So let me say this, if you're desperate and you want inputs and outputs that can control things due to building pressure, get in touch with Leaf because he can build you one now and have you ready to go out the door. You're going to pay for it, and this is what it probably look like.
Yeah.
But there needs to be a plug and play option for this right here. There needs to be something someone creates as a manufacturer that says, here's your pressure differential measurement with, plug power here to power it up. And these are the inputs and outputs you can use off of it. Like that needs to be standardized. And it needs to be a tighter control than what's kind of on the market. Anyway, I've researched that. It doesn't quite exist. That's really awesome yet. And it should. Sorry. Went on my tangent there for a minute.
Nice.
Dude, that is cool stuff, man.
And
I mean, yeah, a lot of these labs, they modulate. They got hoods going off, and yeah, I mean that's so you would hit that middle button right there to like exhaust more air.
No, that was just a display or a little indicator light saying that the system's on.
Oh, cool.
So that
Okay.
someone comes in there, they can quickly know that it's
So
operating.
here's what's crazy. Think about this. There are in Leaf, you do a lot of this work. There's plants that have to like once a year get a building checked for pressurization. Like, hey, this has to be positive pressure or something like that, right?
Yes.
And what's crazy to me is they get it checked once a year, but if you go check it and everything's fine and 1 month later it goes negative, who's checking it?
Right.
Nobody. Nobody. It's not even being monitored, right?
Yeah.
And it's like, what about 11 months? And it's like, well, we got it checked a month ago and we're going to get it checked next year. But it's like, dude, that needs constant monitoring, right?
Yeah.
And that's not happening on a large scale.
It's not, but a lot of the custom equipment, a lot of the equipment in the plants, they have to conform to electrical code, NFPA 496. And so a lot of the custom equipment and some of the panels that we provide, I'm not sure if that one did, but we'll give them some dry contacts. And they're supposed to take those contacts and run them to their control room and have like a little indicator light saying that, hey, I lost pressure or I lost cooling. So it's there, but they never do. Like you said, they won't run them back to the control room typically. And the system always has to be checked on and monitored physically. But yeah, they try to make provisions. It just doesn't always seem to work.
So I got a question that came in that says, is TEC going to come out with an air balancing hood? The answer is yes.
Nice.
But not right now. We are working on it. Sorry. Back to the main show.
I get to find out stuff on my own show. I got to get in the chat myself. I'm just going to ask questions.
There you go.
About TEC. He gives me no inside information whatsoever.
Can't do it, man. You get fired for letting the cat out the bag, you know? I'll tell you what I'm working on, though. You know, like my side projects. You know, well, Leaf knows. We creative. I create the little small stuff that goes out to the world.
Yep.
Like
I gotta get you a tool, man. I gotta get the purge boot.
Gotta get the purge boot.
Because I like it. There was this guy making this little TikTok, and sometimes you gotta sweat stuff in downstairs by the truck. Yeah, I like that. That's cool. You know, like a TXV repair or something.
Yep.
Yeah.
So I want to bring this picture up, Leaf. You sent this to me, and it's got a story. I do not know the story to this one.
What is that? Gas line?
Well, so this is it's actually it's a P trap, And the reason why this one's interesting is because the mechanical engineer that designed the job called out for all the dimensions on the P-trap. So it called out the unit, all the dimensions. I think you have that little picture
Oh,
in the file.
yep. Hang on. Pow. There you go.
Oh wow! All right,
Looks like
hold
it
on.
says 2x2.
Let me
Yeah,
get my
well,
head closer to the
that's a
screen.
different one. I'm sorry. There's going to be
Oh,
another one. You might not have it.
I may not have it.
Okay. Well, we'll go back to that photo then.
Okay.
But so basically, the mechanical engineer says, make the trap like this. The guy in the field makes the trap like this, and it doesn't match. And we're doing commissioning work. So we're checking and verifying that they're doing exactly like the drawings and specifications call, because it's a government job. So in this case, whose fault is it? Is it the mechanical contractor or is it the engineers? But if you look, they have that little slab right there that looks about 4 inches from the photo.
Oh
And
right.
because the unit's not elevated any higher, they can't make the trap like the engineer specified. So what we did was we just asked the mechanical contractor to get with the mechanical engineer directly and come up with a solution. And I believe what the answer was is that when you're dealing with traps, it's all based on, what is the static pressure in the unit going to be and how
Right.
big does the trap actually need to be. So I think they reran the numbers and kind of went into their fudge factors a little bit and said, hey, that elevation's going to be fine. But there will be times when,
The filter
engineers
gets dirty.
draw stuff. Yeah, you draw stuff all the time, but
Right.
you're not in the field. It's the
Right.
mechanical contractors are in the field, and they need to get their job over with. So the best thing you can do, like you're saying earlier, is stop the finger pointing.
Right.
Call them up, get a beer with them if you need to. Work with them and say, hey, look, how can we come up with a solution? We don't want to stop the job. We don't want to cost people a lot of
Yeah,
money.
because I would have said he would have had to rip that whole unit up, put another 4-inch slab under there. 50,
Yes,
50
exactly.
grand.
Raise it, man.
Exactly.
Raise it.
Come on, raise
You
it
know what I'm
up.
And the
You gotta
duct's
rise
already
above it.
connected.
Go to Home Depot and buy like 10,000 of them things you slip in and then pump with your
Oh,
hand.
with the little
You know
pumpies. I love those
Nice.
things.
what I'm saying? Like you're moving
Nice.
furniture. Now, I think about 10,000 of them would probably lift that
Yeah.
unit.
That
You
was
buy,
actually
gotta
our
buy in
second-
bulk.
Yeah, that was our second recommendation. But
Yeah.
but so the point of the picture is that stuff's going to happen, and you just work together. The mechanical contractors, electrical contractors, the engineers, the quality control managers, they all need to work together.
Right.
And fighting and pointing fingers doesn't help anyone. So anyway, so they worked together and they came up with a solution, and everything was fine. So that was the point.
That's cool. You get stuff done. Yeah, I like
Yeah,
it,
you just
man.
gotta get the stuff done. Yeah.
You're like a marriage counselor instead of the husband and wife just pointing fingers at each other.
It doesn't work at my house, but yes, I am. Just kidding. Just kidding.
That's wild, man. Yeah. I mean that's a tiny little slab raise right there.
Yeah.
But that's common. I've seen that a lot
Yeah.
in
It's pretty
commercial.
common.
Yeah,
Yeah.
I've definitely been on a lot of jobs where they pour that exact size height of slab.
But that was kind of the point as well, is that this is a large custom unit, and
Right.
the statics are not going to be typical. And another reason we were talking about the traps, another story that Chris and I kind of went over. We were working on an oil rig that was being built. It wasn't shipped in the Gulf yet. And so on land, they do a million tests. They have commissioning agents all over the place, and all the equipment's being run, checked, verified. And the custom equipment, typically on a rig, there's limited space. So duct pressures are going to be high, and everything's going to be custom. And somewhere along the line, the traps were not designed properly, and the traps actually will go through the hull of the rig. So it's not PVC, it's like hard copper, or
Oh wow.
something that's not easy to change. But the mechanical contractor that was starting to work on it said that the units were filling up with water. So the condensate was developing so much and it could not drain out of the drain lines, and it filled the whole custom units up. One gentleman said like a foot of water. So when he opened up the access door, water just pouring out of it.
Wow.
And so the end user that owns the rig is like, hey, I bought this custom equipment. I have 3 inches double wall liner in there with insulation. And so now you got all my insulation wet. So they had to, on, I don't know how many units, maybe 4 units, they had to remove the evaporator coils. They had to cut out the stainless steel liner, and they had to replace the insulation. They had to put it back, and they had to put the coil back in.
Dude.
And I might be wrong, but I think one of them.
Did they put bubble wrap back in there?
No bubble wrap on these.
That was the second option.
I want to get assured it's the second option.
I think they didn't catch the trap, and then they might have had to redo the same one twice.
Ooh.
But anyway, they figured it out. And if you measure the static pressure in the ductwork and you do the calculations on the one little slide on what the drain should be, they were just way off. And
so what's the static? I'm sorry. Go ahead.
Well, I was just saying, like on residential, sometimes you have standard equipment. It's not that, you may have a drain line issue, you may not. You kind of just follow the recommendations that the equipment manufacturer gives you. But when it's not that straightforward, it's something that can cause you a lot of problems.
Yeah.
So, it happens in residential as well, but you'll see it more on, commercial and industrial where.
Yeah, you guys are like specialty industrial. Like what's the static running on those units?
I think external might have been like 1.5 inches or 2.
Oh,
but,
wow.
The fan itself is developing a lot more to get through the coils and stuff.
Yeah, so that P-trap's real important. That's really weird static pressures, dude.
Exactly. And that's the first time I actually saw that. That's why I remember it. It's like I've never heard. And then I call another engineer guru, and he tells me, oh, yeah, that happens a lot. This is what you have to do. So we're always learning. But to me, that was a good story. I was like, man, I haven't seen that. But,
so like a custom high static unit, industrial, you just play it safe, go with like a real high, like a real big pitch for a P-trap, right?
Well, yeah, you can calculate it based on the blower selection. And, and then that was another thing that Chris and I were talking about is the manufacturers. If you look at their P-traps, they'll tell you. And if you do the calculations, it seems like they're going a little excessive. But I think they never know what people are going to do in the field.
Yeah, it's like worst case scenario, right?
Exactly. Yeah.
And that's what you got. What I've seen around this country is worst case scenario. Yeah.
So I'd always go to if the manufacturer has a recommendation, you do it. If it's a custom unit and they haven't told you, you call the manufacturer and say, hey, what does my P-trap need to be designed like? And let them give that to you.
So, dude, if like, I don't know, man, we started this show, we're trying to like teach new guys like, hey, you could be a building scientist, you HVAC guy, you could be small appliance repair. I got like another niche. You could be working with like Leif, doing like crazy industrial, like what was that, an oil rig you were talking about?
Yeah. You could go work for Leif and go offshore for 6 months and tell your family.
That is cool, man.
That's too much time.
Get on a Bubba Gump shrimp boat and make it out to the
exactly.
That's cool stuff.
But it is all.
You looking for talent, bro?
What's that?
Are you looking for talent?
We do have an entry-level position open at the company.
There you go, Mike. There you go. Anybody wants to go play with it?
I'm going to Louisiana.
You're going into the industrial market, bro.
Dude, it's cool stuff, man.
but it all stems back to the basics. Like you're saying, you're
Yeah.
talking, some people listening to the show are entry level. It's basically saying, hey, look at your traps. And, you
Right.
may not see a lot of problems on the residential side with traps, but they will exist. So the more you
Oh,
know about it, the more educated and the more, you know, you can be valued when something like that happens.
I'm in
So
Florida. I see drain line problems all the
all the
time.
time, huh?
all right.
Yep.
So here's what I want to drop, man. So Leaf, first off, I know we're coming close to that hour, so I just want to drop this out there, man.
Define entry level.
I want to do something nice for you for coming on the show for us.
Yes,
So
sir.
if you are looking for talent and somebody's out there interested, give them a little taste of what you guys kind of like what they do on a day-to-day grind, and where are you located in case somebody hears this show and they're like, man, I'm interested. Like, how do they find you? How does this all play out?
Yeah, so we're in Mandeville, Louisiana, which is like an hour north of New Orleans, and but we do work in Texas, in Mississippi, Georgia, Florida, stuff like that. So a typical day is, we're looking for an engineering assistant. So if we go out and survey a building and we have to get airflow readings and temperature splits and
Right.
layout drawings of how it is and do heat loads, we're looking for someone to help us out on that, where the more senior level people can concentrate on other things. But so we'll get our hands dirty sometimes. Other times we're in the office doing spreadsheets and
Right.
like we were talking, we coat coils, so we'll be doing that. So it's just a whole gambit of different things that we do, just anything to get the work done and keep the customer happy. But
I heard utility player. That's what I heard. Utility
what
player. A
utility?
utility player. Yeah, you do everything. You come
Yes,
here, you do everything.
yes, exactly. You get a
Get the
million
flow
hats.
hood. Get the flow
Yeah,
hood. Get the air
What are we
probe.
doing
Throw it
today?
up in the
Nobody
ductwork.
knows.
Yeah.
Yeah,
exactly.
every
But it
day's a
makes it
mystery.
And that kid would learn
fun.
a lot.
Yeah,
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 but
Right.
yeah.
yeah, that's kind of where we're at.
Cool, cool. Well, if you just heard that and that sparks your interest, you should go to Matrix HVAC and go right underneath Leaf. Hell, I did, and look where I got to.
On your coattails, baby.
That is not
You know what I'm
okay.
saying? Yeah, good
You know,
stuff.
it'd be cool, like even for somebody that's tired of doing like residential installs. How cool would that be, riding around with an engineer, learning
Yeah,
the technical side of the trade, man?
Some engineers, I'm not. You can't put them all in the same bucket. I'm
well,
sorry. I've met some I don't want to ride around with.
yeah,
You know what I
I'm
mean?
with you, bro.
but
I
yeah,
think this is
all of us
Leave.
over here, we're just hands-on guys. We're always working on something. We do the engineering side as well, and consulting firms will do the engineering at a way higher level than
right.
us,
Okay,
but we kind of fit the middle, and that's where we like it, and that's what we're geared
that's
towards.
cool.
And so we work with mechanical
Yeah.
contractors all the time. We enjoy it.
I got one engineer. He threw 16 people in my residential load. I'm not a fan of that guy. And I got the
Yeah,
homeowner asking me, like, "Well, how come your load's so off?" I'm like,
Leave. Let me ask you a question, bro. This is one that's debatable. Um, you've dibble dabbled with residential loads a little bit, but you've been really mainstream in commercial loads most of your life. And then that's kind of that was in our earliest years of knowing each other. That's you were the one who convinced me I should do loads for myself, and
yeah.
and you helped me get started in that. But you know, what would you say is more difficult? A residential load done properly or a commercial load for and I know we have to pick a building because it's all radical, right? Hospitals done differently than a library, done differently for this.
"Wow,
Let's go with something easy. Let's say let's just say a library, right? That's probably an easy commercial design load. Is a library easier or more difficult than a house?
It really depends on how many rooms and how many zones you're doing. But this is the problem with the heat loads. You can design them for residential and was it 62.2,
right,
and but you really don't have any idea how they're going to operate that house. Are they
Right.
going to cook 24/7 with an exhaust fan on that's 700 CFM's exhaust? Or are they going to have monster parties? Or is it just going to be two people living in a 5,000 square foot home all the time with no load?
Keep going.
So,
Keep going.
so
Keep
to
going.
me,
Tell me about it.
the residential drives me
It's
nuts.
crazy, right?
But we're starting to work a little way around that and say, hey, look, if you want it designed to 62.2 at whatever, 74 degrees at 55% relative humidity, this is the equipment we're going to select. Now, if
Okay.
you come back and say, hey, I'm going to have a kitchen hood, I'm going to use it crazy amount of times. Well, if you want that, it's going to be on the drawings and you're going to have to add a DOAS to make up for that kitchen hood because you're using it too much.
Ooh, a
Yeah,
Doaz. The
you're
first
basically
engineer I heard say that. I like
well,
it.
you're not going to like it. Or some of these guys, they'll say, oh, I want it 70 degrees in my house. I'm like, well, that's really too cold. Well, that's what I want. It's like, okay, so line item 3, you want it 70 degrees, the design 74.
Mhm.
Okay, so now we're going to force you to go to inverter. We're going to force you to add dehumidifiers. And we're going to account for when that unit is way the heck oversized and non-peak loads.
we're going to force your
I agree.
insulation package to change.
Yeah.
Yeah.
We're gonna make your walls out of like poly
Yeah.
starboard or something.
Oh,
right?
you want to do bad insulation? No, you're going to have to foam the
I just-
entire house. That's how
I
this
just
works.
don't know what to do with the residential side because they don't understand. And then
right?
what they're asking for is not typical, but they have the money and they're pushing. So
Yeah.
it makes it pretty difficult. So I'd say the residential is
Yeah.
tougher because the commercial, you do it specifically by the codes. They
Right.
agree to the amount of people you're done. But residential,
See,
it's-
man,
Dude,
there you
I
go.
would have thought
You
a
just-
library would be tougher.
no, it's easy.
No, I'll tell you, dude, the hardest one,
Bro.
grocery stores.
Oh man.
It's true.
Yeah, because you
grocery
could have
stores
those
are so
open
hard.
freezers like Walmart just spewing cold air out and like what are you doing?
Leif,
with
give
this?
him a taste of a grocery store design. That's probably in my world. I would say that's probably the
Oh.
hardest one to do.
Like
It's
how do you
exactly what
account? Yeah,
Mike
how do you
said.
account for all that stuff, bro? It's crazy.
So we've gotten in trouble many times because older grocery stores have open spillage. They have open cabinets,
yeah,
and
open
that does
cabinets.
add cooling to the space. But the new energy codes don't allow for that. So an existing store, when they change their equipment out, now they're having to go with more glassed-in type enclosures
Glass
to save
case,
energy and what have you. So so man, y'all got me cornered. But we'll ignore the spillage most of the time.
Right,
Because
right.
we want to make sure we have enough cooling when they spend the money and change out all their enclosures. But so that spillage is a problem, and then you sometimes have to overdo the heat. We'll still do the SCR heat, but having that extra capability, sometimes we'll have to do that, and then like
And then
any other place.
And then you have to think about most grocery stores do like a server line because they make a lot of money on. And I didn't know this till we did a lot of grocery stores together. A
Yes.
lot of the money made in a grocery store is from the deli. The deli is like a huge money
Right.
maker. So
Mhm.
they're running a kitchen hood typically
Yeah.
because they're cooking, serving hot food. That's a big money maker for the grocery store.
Yes.
So you have all of this air being sucked out of the building with so much makeup, and there's a lag.
Yep.
And a lot of these places have 2 or 3 of these.
Yes.
So not only do you have the issue of the spillage, making sure you have air, then there's makeup air that has to be brought into that building, and then it got
Right.
more complex than this. This is another one Leaf taught me is when we had these glass doors, coolers, they would build frost because it'd get too cold, and we needed hot air to be kind of like not hot air, but we needed neutral air, dry air to
Right.
be pumped and dumped right next to the coolers, and that would be put the space. Like here's what I'm going back to. You got this big open area, right? And you got multiple problems going on. You've got cases that are lined up here, there, and yonder, and they're in certain sections of the store. You have kitchen hood exhausts way over there, and they're sucking air out of the building. Well, you would think, well, if I just throw dedicated outdoor air system air to make the building neutral, I'm going to be fine. but it doesn't work that way because the air is not mixing that well. We had to route that DOAS air close enough to the cases where we're blowing the neutral air from the DOAS down by the cases to keep that air warm enough to keep the doors from sweating on the cooler, which we went down the road of doing that on a job. We tried to throw the air in the building. The air wasn't mixing through the whole space very well, so we had to reroute those ducts from the DOAS closer to the cooler cases to make the doors dry up. It was super complex.
And they had heaters on the doors, right?
There's,
The seals, yes. But
just the seals. Yeah. Yep.
yeah, they're I think they're doing something with the heaters on the doors, like backing off on them. But there's one
Really?
more thing though that I love about the grocery store, and I know we got to go. I love it when they say, like, how many people do you have in here? Oh, we'll have 250 people in here. And I'm looking around, I'm counting 10. And I'm like, so when they add 250, the amount of outside air, of course, grows. Right. And so, like, okay, what is your average? What do you want to document? What do you want a size for?
Right.
Do you don't want a size for, egress for, the fire marshal or whatever. But anyway, that's a whole nother story.
Yep. All right, man. Well, you heard it first on the grapevine, man. Residential loads are harder than commercial.
Woo!
I agree.
I heard it on the grapevine.